In lesson 23, we're going to be problem solving using rates, unit rates, and conversions. So if work is being done at a constant rate by one person, at a different constant rate by another person, both rates can be converted to their unit rates, then compared directly. Work can be jobs done in a certain time period, or even running or swimming rates, etc. So basically what this is saying is we are going to be given a rate for two different things, and we're going to bring it down to its unit rate in order to compare them. So how much it is for one of something. So in example 1, it says fresh cut grass. Suppose that on a Saturday morning, you can cut 3 lawns in 5 hours, and your friend can cut 5 lawns in 8 hours. Who is cutting lawns at a faster rate? Now, in this problem, it doesn't tell us what we're going to be setting our rate up as. We're actually going to do it in lawns per hour. It doesn't matter if you do hours per lawn or lawns per hour, as long as you compare the information correctly. So we're going to do lawns per hours. So for you can cut 3 lawns in 5 hours. So 3 lawns, 5 hours. Your friend can cut 5 lawns in 8 hours. Now, this is an important piece. If I'm doing lawns over hours for one of the rates, I have to do lawns over hours for the other rate. So that's just something to remember. The order has to be the same. So I'm doing 5 for 8 for the front. Okay, so if we want to bring it to a unit rate, we want to say how much it is for one of something. So I'm going to see how many lawns in 1 hour. Okay, so for both, I'm bringing it down to 1 hour to compare. So to go from 5 to 1, I'm dividing by 5. So that means I'm going to do 3 divided by 5. So you'll notice you're doing a smaller number divided by a larger number. What that means is I'm going to get a decimal answer or a fraction answer depending upon how you're working. I'm going to use my calculator and I'm going to do 3 divided by 5. When I do that, I get 0.6 or 6/10 of a lawn in 1 hour. That means that I am unable to cut a full lawn, but I can cut a portion of a lawn in that 1 hour. So for my friend to go from 8 to 1, I'm going to divide by 8. So I'll do 5 divided by 8 to see how many lawns in that 1 hour. So 5 divided by 8 gives me 0.625 or 625 thousandths of a lawn in 1 hour. So now I have to look at the units to decide if I want the larger of the two numbers or the smaller of the two numbers. And there is going to be times when you want a larger number to be faster. There's going to be times where you want a smaller number to be faster. It all depends on your units. So if I wanted to cut lawns at a faster rate, I have to think to myself, would I want more lawns in 1 hour to be faster or less lawns in 1 hour to be faster? And in this case, I'm going to want more lawns to be faster. I would want to be able to mow much more than to be considered a faster cutter. So what I'm going to do to compare these two decimals is I need to find the one that's larger. In order to do that, I'm going to line them up by their decimal points. Once their decimal points are lined up, I'm going to attach zeros to the shorter of the two decimals to make them the same length. So this one is shorter, it doesn't have numbers filled in all the way, so I'm just going to fill in zeros. It does not change the value of that number, but it makes it so I can easily compare. When comparing decimals, the first thing I should do is look at the whole numbers. In this case, the whole numbers are the same. They're both 0, so that doesn't tell me anything. Then, since the decimals are the same lengths, I just look at the numbers as a whole after the decimal and compare them that way. So 625 is greater than 600, which means my friend can mow faster than I can. 625 is greater than 600. So my friend cuts at a faster rate. And sometimes you may be asked how much more or by how much. And in that case, you would just take the larger number and subtract the smaller number to find the difference between the two. Okay, let's look at example 2. Example 2 says, next, suppose you own a restaurant, you want to do some advertising, so you hire 2 middle school students to deliver takeout menus around town. One of them, Darla, delivers 350 menus in 2 hours. And another employee, Drew, delivers 510 menus in 3 hours. You promise a $10 bonus to the fastest worker since time is money in the restaurant business. Who gets the bonus? So first off, I'm going to label my equal fractions with the names. So this will be Darla over here, and this will be Drew. That way I can distinguish who is who. I'm going to see how many menus in 1 hour both of them can deliver, and then I'll compare them at the 1 hour. So Darla is 350 menus in 2 hours. So across, I'm going to put menus over hours. If I'm doing menus over hours for Darla, I have to do menus over hours for Drew as well. And Drew is 510 for 3 hours. Okay, I'm bringing it down to 1 because I'm finding the unit rate for each. To get from 2 to 1, I've divided by 2. So I'll divide 350 by 2. And to get from 3 to 1, I divided by 3. So I'll divide 510 by 3. Okay, so I'm going to do 350 divided by 2, which is 175 menus per hour for Darla. And Drew can do 170 menus per hour. So now once again, I'm going to stop and ask myself, if I wanted to be faster, would I want more menus per hour to be delivered or less menus per hour to be delivered? In this case, it would be the number that is greater, so I'm looking for whichever number is higher. Hopefully, looking at these two numbers, you can see that 175 menus is more than 170 menus. So Darla would get the bonus. She can deliver faster. Okay, so again, you want equal fractions. If you have menus over hours here, that means the other unit rate you're trying to find should be menus over hours. So you have to keep it consistent.